Verilog HDL. So Verilog hardware description language, it will be more suitable for to describe a hardware components. Why? Because earlier you studied so many languages. Those languages are used for software purpose. Say example, I can say C, C++, Java. So because as you know, the C++ language is based on the OOPS concept they will call normally. So, but early days and all, if you want to write any programming for hardware, it is not at all possible. But nowadays, what happened? So we can write the programming for hardware. But you may think, why? Why we need to program that hardware? Now let us give you one simple example. Let you consider your LD lab or your digital electronics lab only. In your digital electronics lab, what you might have designed or you might have done some experiment, basic gates, full adder, multiplexer, then counters. But everything, say example, if it is a basic gates in the sense, you might have used IC. Correct. Now you go little bit in your analog electronics lab. In your analog electronics lab, what you will do, you will make a connection with the discrete components. Like if it is small circuit, we can make a simple circuit, we can rig up the circuit, we can verify the output. If it is circuit is small. But you think in the logic design, you are having many number of gates. If as the gates increases, what you do automatically, the complexity of the circuit also will get increased. If the complexity of the circuit also is get increases, then what you need to do? You need a big breadboard. You need example answer. Then if you connect all those things, then it will be difficult for us to verify the output in that. So instead of that, that is why the people has thought why we need to do in that way. So they prescribed or they described they developed one language, that is hardware description language. The hardware description language can be two different types, in the sense two ways, two methods are things. One is Verilog HDL, another one is called as VHDL. Two languages are there actually. So nowadays, presently they are using Verilog HDL. Even VHDL also is more powerful only. These languages are high-level languages we can call. Those C programming, C++ programming, all are high-level languages only. So here, now here in our module 1, what we'll study in the sense, first we need to study about the history of Verilog HDL. What about the history? How it has come, the Verilog. Next, we will study the overview of digital design with the Verilog HDL. In this little bit topic like the evolution of computer-aided design, the emergence of HDLs, then some of the typical HDL flow, then why Verilog HDL, then what are the trends in HDL, that we'll study. Then followed that, we'll study the hierarchical modeling concept here. Here we are having two different modeling concepts. One is top to down design methodology and bottom to up design methodology. Next, we will study something called as difference between modules and the module instance. Then some of the simulations, then we'll see something design block. This and the later will go one by one. So here you may think, okay, if I am designing a one circuit, how to verify my output? Say example, you consider your microcontroller. The microcontroller, 8-bit microcontroller you design. So if you are designing a 8-bit microcontroller, then you need to check whether it is functioning properly or not. How we can check? So possibly giving a proper input, the output you have to check, or you need to do some interfacing and all, then we cross check. Same the way I'll say your digital electronics. In your digital electronics lab or your logic design lab, what you did, you might have done basic gates, or you go for counter, or you can go for any other adders and all. What you did, you used IC, then you given the inputs. The inputs are in the format of toggle switch you might have given. The toggle switches in the sense it will take the inputs as either 0 or 1 only. Then the output will be seen using the LED. When the LED is off, we'll consider as 0. When the LED is on, we'll consider as it is high. So normally we'll check like that only. But when you connect more number of ICs in the breadboard, if there is any issue, so we couldn't be able to troubleshoot where exactly the problem is. So what I can do instead of that, so better, because you think already IC is there. If it is gives any wrong answer over there, then we need to change the IC only. So it is a waste of cost normally. So instead of that, what they will do, first we will design, we'll cross check everything, then we'll go for the IC. That is a proper way we can say. That is why in the market already it's available. That is we can call it as ready-madely IC is available, that we can call it as FPGA. Later we'll study about this. Field Programmable Gate Array. It is a ready-made available IC. So whatever the program you are writing. So if you want to write a program, automatically we know that we need some software is required. So which software we are going to use, because as we are having a lab also is there, Verilog HDL lab is there. So the Verilog HDL lab, which software we are going to use in the sense we are going to use Xilinx 14.5. That is what we are going to use. So let me show that. So what is the software, how the software will look like. I insist everyone to install your machine. This is the software you have to install. So if possible, I will share the link. Actually, you can download and you can install. This is a software we can call it as Xilinx ISE Project Navigator. So here actually what is that in the sense here, in our lab we are having the family as pattern 6, like each and every device will have some family. So here the family is pattern 6, then the device which are going to use is XC6s LX16. This is what they are going to use, then FTG 256. So later we'll study about all those things. See, just I want to show only how it look like. Yes. So now what are the which is software we are going to use? It's a ISC or something I can call it Xilinx XILINX. That is the software. The version which are using is 14.5. So I insist everyone install this software while studying. Just you can execute this program in this, it will be more easier. At the same time, even you can do by online also you can do. Even that also is possible only, but that I will later how. Yes. So now first let us see the history of Verilog HDL. So as I said, Verilog HDL let us started first. First the Verilog HDL is not started. First actually the VHDL only it started. The VHDL it stands for very high speed integrated circuit. So let me show VHIC. Yes. So the Verilog HDL, there's two languages are there. One is VHDL, another one is Verilog HDL. Here you can see the VHDL stands for VHSIC HDL. Actually it is. So the VHIC is So now, so what happened? This is adapted by the EDA vendors. The EDA vendors in the sense, which are the companies we can call as EDA vendors in the sense, like Cadence, Manta Graphics, Xilinx, then I can say Synopsys. So these are the companies I can call as EDA vendors. Those people sort adapted the VHDL language. Later, what happened? The company name called as Gateway, they put the Verilog into the public domain. That the Gateway company later adapted by Cadence actually. So what happened? The Verilog HDL became as commercial in after some during 90s actually. Then that became as more popular among the peoples. So now here, as I said earlier, that by today, if I say the market is divided into Verilog and VHDL, that is the initially we said like two languages, Verilog and VHDL. The VHDL mostly they used in European countries. The Verilog is dominant in US countries actually. So as I said earlier, the VHDL stands for VHSIC HDL, then very high speed integrated circuit HDL. That is the expansion for your VHSIC. Then I can say this is a more general language. One more thing I want to say, if you want to write the VHDL language, like there is no, it's not a structured language. A very important thing. It is not a structured language in the sense, it has some structure actually. Not all constructs are synthesis. Later we come to know what is synthesis. Then you come for Verilog HDL. The Verilog HDL actually is not as general as VHDL actually. But the most of the constructs are synthesizable here. The Verilog language is very, very easy to learn compared to VHDL. Then I can say almost the Verilog will be like it's equivalent to this. I can't say more equivalent, but if you are having the knowledge in C++, then Verilog is very, very easy. So I insist everyone please go and study or have a little bit knowledge in C++ programming. Little bit, I don't want more actually, because I will teach you how to write the programming in Verilog, because our complete syllabus is based on the Verilog only. So each and every circuit will write the programming. So how I will take you into this class in the sense, normally, instead of going for the first module telling all the theories, what I will do, I'll go for initially itself how to write the program first, because we need to do the lab also. So first I will teach how to write the program, then I will incorporate those things with our modules, then it will be very, very easy for you instead of studying directly. So what we will do, let us study about like how to write the program for all the hardware circuits which is given in our book. So for this especially, I insist which book you have to use. Even you can use the book, but I will give the sufficient lecture notes I will give you. So if you study the lecture notes more sufficient, you can score enough marks. Almost you can get 90 plus 95 also you can get from that. So more sufficient. So that material I will give for you. But I insist everyone while taking the course have one notebook. That is very, very important, because it's supposed to be you should write, because while writing the programming, while I'm writing, even you also should write. I'm not going to have the pre-recorded programs, everything. So for you, I will write initially. So later I will consider already which I wrote. Those programs I will take, because it is initially if you understood the basic, then it is very, very easy. But the beginning, the basic, if you don't understand, then the 5 modules very difficult for you to write. So only I'm insisted, don't miss even a single class, at least in the beginning, at least some 10 classes like this, I'm saying, because the 10 classes are more crucial classes, so that can be used in the later for all the module. It will be very easy for you. I will write the program, each and every program I will clarify how to write the program also. So no need to worry about how to write the program, but I need your support. You should write or you should coordinate, should come along with me. So when I write the code, or when I going to write, or when I going to draw some diagram, so you should be able to tell the answers. So only I am insisting, better before coming to the next class, at least go little bit about the digital electronics or logic design. Without knowing the logic design, we couldn't able to do anything here. That is very, very important. So you study in that way, then we can go for better. So that is about today's. Just I want to give some intro about this. So what I will do from the next class, I will start directly from the programming only. I start because that is very, very important for us. So I start with the programming each and every from the scratch I will take. So don't miss the classes. Is there any queries? Is there any queries as of now? So I insist everyone install this software better always. Is there any other queries? Okay, so thank you.